Comparative statics in Roman model. So we have talked about the balanced growth equation in Roman model. We have also talked about the special cases for Roman model. Now we are going to talk about a comparative statics. So let us say there is a permanent increase in the R&D share. That is, if the share of the population engaged in the R&D, that is going to increase. How is this going to affect? So please write this. If the share of the population engaged in R&D increases permanently, right? What is going to happen? One, we are going to assume few things just to make our life little simpler. Mhm. Note that we have already written this point. This thing here. A dot by A is equal to delta LA to the power lambda upon A1 minus 5. We have already written this in the earlier recording, so you might see that. Note that. We have already written. A dot by A equals to theta LA to the power lambda upon E to the power 1 minus 5, right? And when lambda is 1 and phi is 0, so I can just write this as theta LA upon L. LA upon L. So if SR is the share of the population engaged in um, research, engaged in research. So LA is the share of the population engaged in research from the earlier recordings. So, and we are writing this L, so LA is the population engaged in research. I'm sorry. So SR into the total labor force. SR is the share of population engaged in the total population engaged in research. Let's say 25% of people are engaged in research. Total population is 100. So LA is 25% of 100, which is 25. Right? So it is like this. Okay. We have also derived this guy. Remember this. GA equals to lambda n upon 1 minus 5. So remember this guy. So please write in a steady state. In a steady state, economy grows along a balanced growth path. The rate of technological progress A equals to lambda n upon 1 minus 5. But we have assumed lambda equals to 1 and phi equals to 0. Therefore, the rate of technological progress is equal to the rate of population growth. G equals to N. Rate of technological progress is equal to the rate of population growth, which is equal to N. And then you have this. Well, we have what? We have also note that. Note that. A dot by A is equal to theta SRL upon A, right? Because when you are writing A dot by A is equal to theta LA by L, but LA by L is what? Theta SRL, right? I think it should be A. I'm so sorry about it. A. And this also you can write that as theta LA by A. Okay. And what is A dot by A? That is equal to GA. So I can write GA as theta LA by A. So that would mean GA by theta is equal to LA by A. Keep this thing in head. Okay. Now suppose the share of population engaged in research is going to increase. Now suppose SR increases. From SR to SR dash at time period 0. If the share of population is going to increase, it means that of course the population engaged in research is going to increase, right? Therefore, with population of L naught, means the total population at time period 0 is L naught. The number of researchers increases as SR increases. So beta, if this is going to increase, then LA by A, right, jumps to a higher level. What do you mean by this? At time period 0, the share of population engaged in research, that is going to increase, right? So it means that now people who are engaged in research, that is going to increase, LA is going to increase. So this ratio LA by A is going to increase. Okay. When you have more number of researchers, of course, these more number of researchers are going to produce new ideas, more new ideas. the additional researchers produce an increased number of ideas. So the growth of technology is also higher at this point. So at time period 0, when the share of people who are engaged in research, that is going to increase. So the number of people engaged in the research in producing new ideas, that is going to increase. When they're going to produce, when the more people are going to be engaged in research, then naturally more ideas will be generated. With more ideas, technology is going to improve, right? So the growth rate of technology is also going to be higher at this particular point. Okay. Now, if you look at it carefully, which is A dot by A, that is the growth of technology. This is this ratio, LA by A. This is this ratio, LA by A. Now, A dot by A, the balanced growth path, A dot by A is your growth of technology. That is equal to the population growth, right? Okay. Now, this thing, this is also A dot by A, which is equal to theta LA by A. You have just written it. A dot by A is equal to theta LA by A. Fair enough. Where they are equal, that is GA by theta. Where these two are equal, that is GA by theta. Okay. At time period 0, what happens is that, and this GA by theta, of course, you can write that as theta SRL upon A. You can write like that. You can write this A dot by A is nothing but GA. You can write this thing as theta SRL by A, or you can also write this as, of course, I mean, you will be writing this as theta SRL upon A only. So at time period 0, when the share of population engaged in research, that is going to increase. So I can write this as theta, I can write this as SR dash L upon A. But here the labor force is this guy, and this is your A naught, right? Fair enough. Acha, you tell me one thing. This is one more thing. LA is SR into total labor force. So with the new share and the labor force at time period 0. So the people engaged in research is A, your LA dash or whatever. Okay. This particular point is labeled as X. This particular point is labeled as X. Now, at X, what is happening? At X, you can see the growth rate of technology is more than the growth rate of population. In the balanced growth path, the growth rate of technology and the growth rate of population is same. But at X, what you can see is that growth rate of technology A dot by A is more than the growth rate of population N. That is exogenously given. At X, technological progress A dot by A exceeds the population growth N. So LA by A falls over time. Falls over time, right? LA by A is falling over time. Technological growth rate is growing more than the growth rate of population. Beta, when population will increase, then only the people who are engaged in research that will increase. But the rate of growth of population itself is lesser than the rate of growth of technology. So if I look at how A is growing, so A is growing at a faster rate than the growth rate of the labor force. And if the labor force growth rate uh, is going to grow at the slower rate than the growth of technology, then LA by A is going to fall. Are you understanding this? What I'm trying to say is this. When L is increasing at the rate N, then out of this L only, there'll be some people who are engaged in research. A is increasing at the rate whatever, right? That is increasing at the rate GA or whatever. Now, this is growing faster than this. So naturally, when denominator is going to grow faster than the numerator, LA by A is going to fall over time. So when they're going to fall over time, it's going to fall like this, right? So as the ratio decreases, over time, the rate of technology, even this GA by this A dot by A, that is also going to fall over time. The rate of technology gradually falls over time until the economy returns to the balanced growth path where GA is equal to N. Where GA is equal to N. So if you look at it carefully, I mean, the time path is going to be like this. The time path is going to be like this. Here you have the growth of technology, here you have time, and here you have this T or whatever, right? So it increases this thing till here, and here you have GA equals to N. So it increases. And the same thing then gradually falls. This growth rate falls like this. This growth rate falls like this. And then Jones beautifully writes this. Therefore, even if there is a permanent increase in the share of population engaged in research, It can increase the growth rate temporarily, but eventually it falls back. Growth rate of technology temporarily, but not in the long run. Therefore, the permanent increase in the share of population engaged in research increases the rate of technological progress but not in the long run. Not in the long run, right? Okay, I'll take the discussion further in the next class. Thank you, Betty.